says, which three-dimensional figure does this net represent? And if you don't know what a net is in math, basically it's just a two-dimensional figure that represents a three-dimensional figure. When the three-dimensional figure is unfolded. For example, on these answer choices here, these are three-dimensional figures that look like boxes. Okay, they've been folded up. But if you unfolded those, all the sides of those boxes, you would get something that looks like this. And that's called a net. Okay, so we need to think about what would happen when we fold this net up and make a box out of it. So this piece would fold down, this piece would fold down, and then these four pieces would kind of wrap around each other. Okay, and this would be maybe the front, this would be the top, the back, and the bottom. Okay, just depending on how you fold it up. But if you did fold those up, then you want to think about what this piece would look like in relation to these pieces. And if you notice on your answer choices, answer B, notice how it has a long line across one of these sides. Well, that would be a long line across here like this. So that one's definitely wrong. Same thing with answer D. Okay. Now answer C looks like it might be right, but if you notice this mark here is not right above this circle. Okay. Actually it's above it, but it's kind of to the side. And over here, the mark and the circle are right on top of each other. And that's what answer A shows you. So answer A is correct. So you've got to think about what the pieces will look like once they're folded up. Okay. Number 2, you're going to fold this up. This is going to be a triangular prism. Up here we have a rectangular prism. Okay, this is a triangular prism. The bases are going to be triangles, and then you're going to have 3 rectangular sides. Okay. When you fold this up, you're definitely not going to get this big triangle like this, or this. Okay, so we can rule those 2 out. And notice answer B has this triangle down here on this end. Okay, so answer C is the only one that it can be. You got the black mark here, which would go here, and then you got a triangle right here, which would be that triangle. Okay. Which of the following is a true statement about the net of the cube shown below? Okay, once again we have a net, and this is a cube. Think of a dice or a die that you roll. Okay, that has those letters on it. That's what you would see if you folded this up into a cube. Okay. Now they're asking us about parallel and perpendicular faces. Okay, so if you fold this up, okay, let's pretend that the S is going to be on the top here. Okay, the S is going to be on the top. If you fold the E down, the E is going to be on the front side, the U would be on the back side, the K would come down and be on the left side, the A would be on the bottom, and the T would wrap all the way around to the right side. Okay? So that's what you would have. Now, you know parallel lines are two lines that go together. Okay? Parallel faces are going to be real similar to that. Look at this box. Okay. On this box, this front face and the back face back here would be parallel because they would run parallel to each other. Or the top and the bottom would be parallel. Okay? Basically any two faces that don't touch each other are going to be parallel. Whereas the left side and the top, those would be perpendicular faces. Okay? So any two sides that touch each other in this figure will be perpendicular. So let's think about that when we're answering these. Look at these choices. K and S are parallel. Well, K and S, since they touch each other, they're going to be perpendicular. K and S are perpendicular is answer B, so answer B is correct. Okay. Number 2, R and A are parallel. Well, since they touch each other, they're not parallel, they're perpendicular. A and N, those are perpendicular, they're not parallel. R and D they're going to be parallel because they don't touch each other. So they're not perpendicular. So it must be answer D. A and D are perpendicular, and they are. Number 3. M and T are parallel. And that's true because M would come down and be on the right side of this cube. T would be on the left side, and they would be parallel. Okay, a hexagon is graphed on the coordinate grid. Which two coordinate points lie on the line of symmetry of this hexagon? Okay, line of symmetry. Basically, if two things are symmetrical, it means that they're the same on the left and the right side, or top and the bottom. Okay, and if you draw a line of symmetry, the line of symmetry is kind of like a mirror, and on both sides of the mirror you have the same figure reflected. Okay, so on this figure, our line of symmetry is going to be right here. Because everything over here is reflected over here. If you look at it, everything here is reflected down here across that line of symmetry. Now, it's important to remember what a line is. Okay, a line does not stop here and here. It keeps going both directions. So you want to think of that as a line that continues in both directions. And now we need to find two coordinate points that lie on that line. So basically what you need to do is go through these answer choices and graph them until you find a pair that are both on this line. Okay, and our answer is going to be D, because 0, -2 is here, and -5, -2 is here. Okay, both of those points lie on that line. Now on these others, there may be one point that lies on the line, but they both don't lie on the line. Answer D is the only choice where both points lie on the line. Okay, number 2, line of symmetry. The line of symmetry is going to be right here, okay? Because everything up here is reflected across this line of symmetry down here. Once again, our line keeps going both directions. And then you just need to find a point, or a pair of points, that are both on that line. And our answer is going to be D. 3, 1 is here. And -1, 1 is here. Those are both on the line. Which of the following is the most precise name for the figure LIME with these vertices? Okay, so I'm going to graph these ordered pairs that they're giving us. 5, 2, and on these graphs, make sure you count your lines. It can be confusing because 5, when you read the 5, you could think of the 5 as being here, but it's actually over here. If you count from 0 right here, 1, 2, 3, 4, 5, you'll get it right. On the Y's, it's really confusing because they've put 1 up here. You might think 1 is this line, but actually 1, okay, here's 0, here's 1, here's 2. Okay, so just make sure you count each time from the origin when you're graphing these. These graphs that you're given on these worksheets, I'm not that crazy about because of the way they number them, but just make sure you count. Okay, the next point is 6, 6. Here's 6, 6. -2, 6 is going to be here, and -3, 2 is here. Okay, so there's our figure. We want to connect the points. And you can see that figure is not a rectangle. It looks kind of like a rectangle, but since the sides are slanted and you don't have right angles, you don't have 90-degree angles in here, it's a parallelogram. Okay. Number 2. Graph the points. -1, -3, -1. Connect your points. Okay. It's not a rhombus because rhombus is like a slanted square. It has 4 equal sides that are slanted. Looks a little bit like a rhombus, but all 4 sides are not the same length, so it's not a rhombus. It's obviously not a rectangle. Parallelogram has each pair of sides are the same length. Like up here in this parallelogram, these 2 sides are the same length. These 2 sides are the same length. But down here, these top and bottom sides are not the same length. The left and right sides are, but the top and bottom are not. Okay, this is the definition of a trapezoid. You have one pair, exactly one pair of parallel sides. Okay, and that's what you have there. Okay. On a parallelogram, you have two pair parallel sides. These two sides are parallel, and these two sides are parallel. Same with a rhombus. Both sides are parallel, or both pairs of sides are parallel. And on a rhombus, all four sides are congruent. They're the same length. On a trapezoid, you have one pair of parallel sides, and those are right here. Okay? Now on a trapezoid, these other two sides don't have to be congruent. Okay? They are in this case. And it's a special type of trapezoid called an isosceles trapezoid, but they don't have to be congruent. But you do have to have a pair of parallel sides for it to be a trapezoid. A trapezoid could also look like this. Okay? Not a good picture, I know, but okay. Sorry. It's hard to draw like this. There. Okay. There's another type of trapezoid. You got a pair of parallel sides right there, and that makes it a trapezoid. Okay, line T is shown below. Which equation best represents a line parallel to T? Okay, let's go back to our equation for slope. Remember, slope is rise over run. Okay, so we can find the slope of this line. It goes up 1 over 2. So the slope is 1/2 for this line. It's a positive 1/2. It's positive because it's going up. And it's going up 1 as it goes over 2. So the slope, we call the slope M. M equals 1/2 for line T. Now remember in our slope-intercept form of an equation, and this is on your formula chart for tags, y equals mx plus b. That's a very useful formula to remember, because if you have a line in this form, it's easy to see the slope, m, is right here. It's the number that's in front of the x. So look at these answer choices down here, and you can immediately see what the slope is on each one. Okay, this one has a slope of 1/2. This one has a slope of 2. This one has a slope of negative 1/2. And this one has a slope of negative 2. Okay, it's very important to understand that, because when we talk about parallel lines, okay, remember a parallel line is going to look like this. Okay? Those two lines are parallel. And the thing that makes them parallel, and the way you can check to see if two lines are parallel, is to see if they have the same slope. Okay? Both of these lines are going up 1 over 2. Up 1 over 2. Okay? Remember this one, we already measured it. It was going up 1 over 2. Up 1 over 2. And no matter where you're at on that line, if it is a line, it's always going to have the same slope, no matter where you're at. Okay? Even if I'm here, up 1 over 2, it's still 1/2. Okay? So here's another line that has a slope of 1/2. So what I'm getting at here is that a line that's parallel to t is going to have the same slope as t. And we already know, because we calculated it, that the slope of t is 1/2. So whatever our answer is down here is also going to have a slope of 1/2 because it's parallel to t. And you can see right here that answer A has a slope of 1/2. Okay. Number 2. Same thing. Which equation best represents a line parallel to t? So let's find the slope of this line. And all you do is you count 1, 2, 3. So the rise is 1, 2, 3, but it's going down, so it's -3. And the run is 1, 2. So it has a slope of -3/2. So a line that's parallel to that line is also going to have a slope of -3/2. And here it is. There's your line that has a slope of -3/2. Okay, the number in front of the x is the slope. Whenever your line's in this form, whenever it says y equals, your slope is going to be your number that's in front of the x. Okay. Now, we gotta learn something else here. Because now they're asking us about perpendicular. This says, which graph best represents the line passing through point 03 and is perpendicular to this line? Okay. Now, before we go on, let's just go ahead and look at this point. Because they're telling us that the line passes through point 03. So whatever we choose down here has to pass through point 03. This one doesn't, so I can rule that out. That one does. That one does. And that one does. Now you didn't really have to do this step, but I wanted to go ahead and show you this, just to remind you of what this means. Okay, the line has to pass through that point. Now, perpendicular. I want to write this. Perpendicular lines. You need to write this on your sheet. Okay. Perpendicular lines have slopes that are, okay. Now remember, with parallel lines, we already talked about this. Parallel lines are easy because they have the exact same slope. Now, perpendicular lines, remember what they are. Okay, a perpendicular line looks like this. Okay, it's two lines that form right angles. Okay, and if you notice, this one has a negative slope, this one has a positive slope. They're obviously not the same slope, but they are related to each other. Okay, and the way they're related, and I just showed you one way they're related is that one's negative and one's positive. So perpendicular lines have slopes that are opposite. We'll just say opposite signs. Okay? So that's one way they're related. They're opposite signs. And they are also reciprocals of each other. So we'll just say there are opposite signs and reciprocals. So if this line has a slope of 2/3, okay, this line has a slope of 2/3, then the line that we're looking for that's perpendicular to that line is going to have a slope of, okay, they're opposite signs, so it needs to have a slope of negative. Since this one was positive, this one's going to be negative. And they have to be reciprocals. So the reciprocal of 2/3 is 3/2. You just flip the 2 and the 3 and make it 3/2. So the slope of the line that we choose is going to be negative 3/2. And you can see this line right here goes down 3/2. So the slope is 3/2. Okay. Okay, on this one, which graph best represents the line passing through point -2, 0 and is parallel to x equals 5? Okay, the reason I chose to do this problem is because you need to understand what this line is right here. X equals 5. Okay, normally when we do these lines we have y equals something, okay, and it's something you can plug into your calculator at the y equals button. But when it says x equals something, there's nothing you can plug into your calculator with that. You just have to kind of understand what this line means when it says x equals 5. Basically, it means just what it says, okay? This describes a line where the variable x, or the x on your graph, okay, is always equal to 5, okay? If that's the only thing we know about this line, x equals 5, then you just draw the line where x is always equal to 5. And what you're going to get, look at this graph here, okay? Your x-axis is your horizontal axis here, okay? Where on the x-axis is x equal to 5? Positive 5. Here's 1, 2, 3, 4, 5. Okay. So right here, x equals 5. Now, I could also go up here, and x would still equal 5, wouldn't it? Or down here, x would still equal 5. Okay. So what you've got is a line. It's going to be a vertical line like this, where x is always equal to 5. In other words, if I picked any point on that line, I'm going to pick these 2 points right here. And I put in the coordinates for those 2 points. That would be 5, 2. This would be 5, -3. Okay, no matter what point that I pick on that line, look what's going to be true. X equals 5. And look at it. X equals 5. X equals 5. Okay, so that's what that means. So here's the line, x equals 5. We need to find a line that's parallel to this that goes through point -2, 0. Well, it's pretty easy to find a line that's parallel to this, because this is a vertical line. A line that's parallel to it is also going to be a vertical line. So this is going to be the answer. Okay. This part you didn't even need, but you can see that this line does pass through point, -2, 0 right here. Okay. Now, all of the lines actually pass through -2, 0, if you notice. Okay, there. But this one is parallel to the line x equals 5. Okay. So while we're talking about this, if you had a line that was y equals 3, okay, where would that line be? Well, it's exactly what it says. And this one you can actually plug into your calculator. You just go to y equals and you put in 3 and you graph it. But in this case, instead of a vertical line, you're going to get a horizontal line. Because when y equals 3, go up to 3 right here. Y equals 3 right there. It also equals 3 right here and right here, doesn't it? So the line y equals 3 is a horizontal line. Okay? And it would be parallel to this one. Okay? So those are two special types of lines. When you have one that says x equals some number, like 5, or when you have one that says y equals some number, like 3. This one's going to be vertical, this one's going to be horizontal. Okay, which graph best represents the line passing through point 0, 4? Okay, point 0, 4. Notice all of them actually pass through that point, and is perpendicular to y equals 3x. Okay, remember, here's our slope-intercept form of a linear equation. Our m, in this case, is 3, okay? So our slope is 3. Remember, you can write the whole number 3 over 1, okay? That puts it in rise over run form so that you know that this line is going to rise 3 and it's going to run 1, okay? Just while we're on this one, what would the b be in this equation? Y equals 3x plus b. Well, there's nothing out here for b, so you could put 3x plus 0. Okay? So the b would be 0 in this case. Remember, the b, we talked about it before in one of the earlier objectives. The m is the slope, the b is the y-intercept. So this line, y equals 3x, would have a y-intercept of 0, and a slope of 3, or 3 over 1. Okay. Now, back to our problem. This line that we're looking for is perpendicular to y equals 3x. Well, y equals 3x has a slope of 3 over 1, so our perpendicular line is going to have a slope of, remember on perpendicular, it's the opposite sign. So since this is positive, this one's going to be negative, and we have to take the reciprocal of this. The reciprocal of 3 over 1, just flip the 3 and the 1 and make it 1/3. So our slope that's perpendicular to this line is going to have a slope of negative 1/3. And I believe this is the one. This one goes down 1 over 3. So that's a slope of negative 1/3. Just take that number, divide it by 4, and we'll get the length of one side. 6 feet. Okay. Number 3. Get a circle with a diameter of 26. She used all the fencing from the circular garden. Okay, once again, we're using the outside, so we need to find the length of the circumference to enclose a square dog run. And we're going to make a square. So it's just like number 2. Diameter is 26. Circumference equals pi times diameter. So pi times 26. Is about 80, close to 82. I'm going to round it up to 82. And we're going to take that edging that's 82 feet long, divide it by 4 sides, 4 equal sides in a square, and we get about 20 for each side. Length of each side is about 20. Okay, number 4. We have a circle with a radius of 3 units. And radius is 3. And we're going to take it and change the shape to a square that has approximately the same perimeter. Okay, so same perimeter as the circumference of the circle. It's the same thing we were doing up here. The sides of the square will be, okay, so let's find the circumference. And the radius is 3. Circumference is 2 pi times radius. Notice I'm using the formula that has radius in it. Up here, I use the formula for circumference that has diameter in it, because we were dealing with diameter in this problem. Here, we're dealing with radius. Okay? 2 pi radius, so that circumference is going to be 2 times pi times 3, and that's about 19. Rounded up to 19. And they want to know the sides of the square, so we need to divide that by 4. And we get about 4.7. Okay. Okay, one thing that I want to go over with you before we start this is the idea that a triangle, when you take a triangle, and this is true of any triangle, the 3 angles, when you add them up, equals 180 degrees. Okay? And you really need to understand that. I mean, that's something you just need to memorize. A triangle, the sum of the angles equals 180 degrees. And we're going to use that idea in this lesson quite a bit, so make sure you understand that. Now, if I take a rectangle, now you know a rectangle has 4 90-degree angles in it, so you could just add those up and find that it equals 360 degrees. Okay. But if it wasn't a rectangle, and it was just some 4-sided figure like this, quadrilateral, that's not very good, but yeah. Okay, it's not a rectangle anymore, but it is a 4-sided figure. one thing you could do is divide it up into two triangles like that. And since we know a triangle is 180 degrees, then two of them have to be 180 times 2, which is 360. Okay. If you have a five-sided figure, like that, I'm going to pick one point here, right here, and I'm going to draw triangles out from there. There and there. How many triangles do I have? There's 3 triangles, so I could say 3 times 180 equals 540, and so on. Okay. Every time you add another side, you're going to be able to draw another triangle in there, which is going to add another 180 degrees to the total sum of the angles. Okay, so let's use this information and apply it to this problem. Number 1, in the figure below, line segment JA here is parallel to line segment EI, and line segment NI is perpendicular to EI. So that makes a 90-degree angle. The measure of angle JAN is 110 degrees. Okay, JAN. Here's J, here's A, here's N. So JAN is this angle right here. And we're given that it's 110 degrees. Now we know these are all 90, so that's what the little symbol there means. So right angle, so it's 90. So we know those 4 angles, and they want us to find the measure of angle ANI. ANI, right here. So we just need to find this missing angle. Well, since it's a 5-sided figure, we can use this one, and from that we know that there needs to be a total of 540 degrees in these interior angles. Well, we've got all our angles except one, so what we can do is add these up, add these 4 angles up, and you get 380. And then you just subtract 380 from 540, and you get 160. So you would bubble in 160 just like that. Okay. The way we did this down here, here's my 5-sided figure. I'm going to draw my triangles there and there. 1, 2, 3 triangles. 3 times 180 for each triangle equals 540. Okay, number 2. Once again, we have a 5-sided figure. So again, it's going to be 540. If you want to draw the triangles, you can. Got 3 triangles. 3 times 180 is 540. So all these angles need to add up to 540. We know these 3 are 90. 90 times 3 is 270. Okay? And we don't know these 2. Now they're asking us for EPA, which is this angle right here, EPA. But we don't know it, and we also don't know this one, ENT. But we do know that these 2 are congruent. Their measures are equal. So if we take the 270 away from the 540, it leaves us with 270, which is what we've got left here. These 2 angles have to add up to that remaining amount of 270. And since they're equal, these two angles are congruent, then I can just divide 270 by 2. And I get 135. So I'll bubble in 135. Each of these angles is 135. And then all 5 angles would then add up to 540. Okay? I'm going to erase this. Okay. FR is parallel to EM and perpendicular to FE. The measure of FRA is 130. So I fill that in. And EMA is 125. Okay.
I gotta go.
Okay.
You wanna,
So we know four angles here. We just need to find RAM, which is this angle here. And that's the angle that's missing. So 90, 125, 130. Add those up, and you're going to get 435. Subtract that from, it's a 5-sided figure, so we've got to add up to 540, and then you get 105. Okay. Number 2. All right. There's something a little different. Notice how they spelled out hexagon right here. This is a hexagon. It's 6 sides. It's a 6-sided figure. If you want to go ahead and draw your triangles out, there and there. How many triangles are there? There's 4. 4 times 180 is 720. So these angles need to add up to 720. And whenever you have something like this where all the sides are congruent, then all the angles are also going to be congruent. This is called a regular hexagon. It's called a regular, any shape that's all the sides are congruent, it's called regular. This is a regular hexagon. So all the angles are going to be congruent, so we can just take the 720 and divide it by the number of angles, which is 6. And that equals 120. Angle HEX. That's one of these angles here, right there, but they're all the same. They're all going to be 120. So 120, just like that. Okay. In the figure below, 1, 4, 5, and 8. 1, 4, 5, and 8. These 4 right here are congruent to each other. And 2, 3, 6, and 7. 2, 3, 6, and 7. Those are congruent. And the measure of angle 1 is 120. Okay, so here's angle 1. It's going to be 120. But if it's 120, I can't write that small. 120. If it's 120, then we know 4, 5, and 8 are also 120. Okay? Like that. What they want to know is, what is the measure of angle 2? Okay. I'm going to go ahead and erase this. We need to find angle 2. And we know 2, 3, 6, and 7 are all congruent. They tell us right here. What we need to know is how many degrees are in this entire figure. So we can draw our triangles. I'm going to start here at angle 1. I'm going to go up here, here, go to every vertex. There, and there. So I've got 1, 2, 3, 4, 5, 6 triangles. So you do 6 times 180, 180 for each triangle, remember? And that gives me 1080. So I have 1,080 degrees total in this figure. Well, we were told that this is 120, which makes these others 120 here, all 4 of these. So I could say 4 times 120 equals 480. Subtract that from 1080. Leaves me with 600. Okay, so there's 600 degrees left, which has to be split up between 2, 3, 6, and 7. And since we know 2, 3, 6, and 7 are congruent, then I can just divide by 4. 600 divided by 4 equals 150. Each one of those angles, 2, 3, 6, and 7, is going to be 150 degrees. Okay. So angle 2 is 150 degrees. Number 2. Got a 4-sided figure, which is like a rectangle. You know rectangles are 360 degrees. But if you want to draw your triangles out, it would look like that. We form 2 triangles. 2 times 180 is 360. So 360 degrees. And we know these are 90. So 90 times 2 is 180. Subtract that from 360. That leaves me with 180 degrees to be split up between these 2 angles. And what I can do here is just write an equation based on what they're naming these. One of them is 2x, one is x. That just means that this one is 2 times this one. So I can say 2x plus x adds up to 180. So equals 180. And then I can just solve that for x. 2x plus 1x is 3x. So x equals 60. Okay, now you got to be careful though. Is that the answer? Let's go back and read the question. What is the measure of SID? Here's SID. So we're talking about this angle. Okay, we're not talking about x, we're talking about 2x. So if x is 60, then 2x is 2 times 60, which is 120. Okay. And we talked a little bit about this before. When I've got angles like this is something you really need to memorize. When you see a figure like this, where you have, these are called vertical angles, okay? These are congruent, okay? Since this is 50, and this is 50. Vertical angles, okay? These 2 angles would also be vertical. They would be the same. This one would be 130, this one would be 130. Okay, remember 50 plus 130 equals 180. So that would be 130, that would be 130. We don't need to know that here, but just a reminder. Okay, so since that's 50, we know this is 90. So this has to be triangle has to add up to 180, so this has to be 40. Okay, so your answer is A. Number 2. Okay, they're telling us that this right here is 38 degrees, which means this is 38. Okay, and what they want to know here, this courtyard is formed by the intersection of these four streets. And they've kind of colored it in here. I'm going to go ahead and color it in a little more. I'm talking about this triangle right here. That's the courtyard. Okay. So right here. They want to know the measures of the angles of the courtyard. Show me 3 angles. Well, this one's 38. If this is 38, then this, since that's 90, then these two have to be 90, okay? Because all together those have to equal 180. So this, since this is a right angle here, this has to be a right angle. So these two have to add up to 90. They're complementary. So 38 plus 52 equals 90. So that angle is 52. That's one of the angles in our courtyard. This one is obviously 90. So 52, 90, and then this one has to be 38. So that the angles of the triangle add up to 180. So 52, 38, 90.